Hello and welcome. Today, we're diving into the world of logistics and supply chains, specifically looking at how mathematics helps make everything run smoother. Think about how goods get from a factory to your doorstep. It's an incredibly complex puzzle. Mathematical optimization is the science of solving that puzzle in the best way possible. At its core, optimization in logistics means using math, models, and algorithms to improve processes. We're talking about transportation, managing inventory, designing warehouses, and planning the entire supply network. The main goals? Usually, it's about cutting costs and delivering products faster and more reliably, all while working within real-world limits, like budgets or truck capacity. Why is this so important now? Global trade is complicated. Demand can swing wildly. Disruptions happen, and customers expect quick, dependable service. Companies that use optimization gain a real edge. They see lower transport costs, less money tied up in inventory, faster deliveries, and even more accurate predictions of future demand. So, what kind of math are we talking about? Several key techniques are fundamental. First, there is linear programming, or LP. This is great for problems where you want to minimize or maximize something straightforward, like minimizing fuel costs, given a set of linear constraints. Think finding the cheapest way to ship goods using different routes and carriers. Then there's mixed integer linear programming, or MILP. It's like LP, but some decisions are yes or no, or involve whole numbers, like deciding whether to open a new distribution center or assigning a specific truck to a route. This adds flexibility for real-world scenarios. Sometimes problems get incredibly complex, like planning routes for hundreds of vehicles visiting thousands of locations. For these, exact methods like LP or MILP can take too long. That's where heuristic algorithms come in. These are clever techniques designed to find good, practical solutions quickly, even if they aren't mathematically perfect. Think algorithms that make sensible choices step by step, or mimic natural processes like evolution or annealing. We also use simulation. This lets planners build virtual models of their supply chain and test different what-if scenarios, like changing inventory policies or warehouse layouts, before making expensive real-world changes. It helps understand how complex systems behave over time. Where is optimization applied? Pretty much everywhere in logistics. Route optimization is a big one. Finding the best routes for delivery trucks to save time, fuel, and money, while respecting delivery windows and driver rules. This often involves tackling variations of the famous vehicle routing problem. Inventory management benefits hugely. Optimization helps determine exactly how much stock to keep, where to keep it, and when to reorder, balancing the costs of holding inventory against the risk of running out. Warehouse optimization focuses on efficiency inside the four walls, designing layouts, deciding where to store products, slotting, and planning the fastest ways to pick orders. Network design uses optimization for big strategic decisions, where to build factories or warehouses, and how large they should be, aiming to minimize total costs across the entire supply chain. And things are getting even smarter. Traditional optimization is powerful, but it's being turbocharged by artificial intelligence and machine learning. I can improve demand forecasts, predict traffic or disruptions, and enable systems to make smart decisions automatically, sometimes in real time. The flood of real-time data from GPS, sensors, and traffic feeds makes optimization models much more responsive. Plans can be adjusted on the fly based on what's actually happening right now. There is also a growing focus on sustainability. Optimization models now help minimize carbon footprints alongside costs, looking at greener routes, electric vehicles, and more efficient network designs. In essence, mathematical optimization provides a rational, data-driven way to tackle the immense complexity of modern logistics. By clearly defining goals and constraints, businesses can find efficiencies they might otherwise miss. As supply chains face increasing pressure, using these mathematical tools, enhanced by AI and real-time data, isn't just helpful, it's essential for success. Thanks for tuning in.